All right, there we go.
Okay, wonderful. So welcome everyone to the HamSCIence Zoom call. Today, I think is Thursday, January 16th. I'm going to flip over real quickly to an agenda page because I originally worried we wouldn't have enough to talk about, and we've probably got too much now. So let me share real quick, just so everybody knows what I'm thinking here. Wow. New operating system always brings with it new challenges and stuff. So hopefully you guys are seeing my my agenda screen.
Right.
Mm-hmm.
Great. Okay. So a couple of things I just did want to mention briefly that the HamSCI workshop, of course, is scheduled for about 2 months from now. The abstract submission period is now open between now and February 10th. If you've got any questions or want to read about it or actually make a submission, you're welcome to ask questions and talk about it here, or go to hamsci.org where you can pretty easily find the links to make the submission. Nathaniel or Gareth, do you guys have any comments on the workshops or the abstracts before we move on?
Gareth, do you have any comments?
Other than we're looking forward to many abstracts. And encourage everybody, even if you're not sure if you should submit one, just ask us at this meeting here or ask Nathaniel or anybody, and we'll probably tell you yes, submit it. So we're looking forward.
Yeah, and abstracts can range for things from like traditional presentations to poster presentations to demonstrations. So if you have some sort of a widget, or as Dr. West would like to call it, I think a who's what's it, technical term, that you want to show to people, you can submit that as an abstract, and you feel free to put some additional comments into the organizers that they can get that about your needs. Also, we have Gareth tells me that they're in the process of setting up the registration system, but it's going to take some time. So what you should do is just, if you're planning on going, get your abstract in as soon as possible, number one, if you're thinking of presenting. And then number two, if you're planning on going, just go ahead and put it on your calendar for now. Registration, where you actually pay for the tickets and the food and stuff, that will probably open up about a month from now. So it will happen, but it's going to take them about a month to get that system in place. Gareth, do you want to say anything about hotel reservations or things like that? Where is that?
Yep. Hotel reservations are going to come pretty quick. Maybe as early as tomorrow. Information about that will be posted on the website at the latest early next week.
Wonderful. Thank you.
But you're right. The registration will be a little bit later.
And we'll, of course, let everyone know by the main HamSCI Google group, of course. So that's it's the easiest and quickest way for us to get the word out. Okay, anything else in the workshop? We'll move on. Good. Okay, thanks for the update. Dr. West is going to talk a little bit today about the Tonga explosion. I had asked her, she had volunteered actually a couple of times in December, but we kind of ran out of time at the end of the year. So now is going to be an opportunity to see some interesting facts about the Tonga explosion. We may want to make a few comments about the Orlando Hamcation because Ed's here today, and I know we had some discussions earlier this morning in the 10 a.m. Zoom. And then I think the main thing we want to accomplish once we get through that is probably to talk about the future Telecon topics and speakers. So we've got a steady diet of a good information flow going through everyone. And after that, we've got a couple of other topics that we can either fill time with or perhaps put off till next week. We'll have to see. So any questions about that? Or otherwise, I'll stop to share. Go back to Zoom if I can. Close. Oh boy, new software. That's better. Wonderful. Okay, if nothing's further, I'd like to turn the floor over to Dr. Mary Lou West, who will talk to us a little bit about Tonga.
Okay. Well, let's see here. Mhm. You can't get to slideshow because they cover it up.
You can just press F5.
Ah, that's good to know. F5. There we go. So at any rate, I thought I'd tell you about how the Tonga volcanic explosion disturbed the ionosphere. Woo! And how ham radio contacts showed that it did that. So I think that's the interesting part, really. But at any rate, this was a really, really big explosion. The volcano was an undersea volcano because previously had blown the top off the thing. And so there's just this cone under about a mile of seawater. So it's pretty deep. It did have a little ring at the very top, and there were some fishermen on that unfortunately got killed. So this happened on January 15th, 2022 at 4:15 Universal Time. The thing had been burbling and smoking for almost a month. So mid-December, little gasps of steam came up. But it did that from time to time. So nobody really thought much of it, evidently, but they should have, I guess. The Tonga archipelago has many islands, and this one is called Hunga Tonga Hunga Haiapai, or some such. Once it blew up, tsunami warnings were issued for the whole Pacific Rim. And in this map that I have in the upper right, the darker gray is where the tsunami warnings were taken seriously. So in the lower left, we have Australia and New Zealand. And then in the upper left, we have Japan. Then we have the United States in the upper right. And then the coast of South America running down on the right-hand side. And evidently they were taken seriously by almost all the groups. They cleared the beaches, except for one beach in Chile where the person decided, they're too far away. We're not going to do that. So they did not clear the beach, and a big wave came in, took 2 people out, and they drowned. So I think that's that's too bad, but they decided that. All right, this thing blew up and had a vertical plume of gas and steam and ashes that went 50 kilometers up into the sky. It was the highest plume ever sent from the Earth's surface to go up. So it was pretty amazing. People who calculate from that and from other indications what the total energy input to the system was, say this was the most energetic single event ever in the history of the world, and even more than Krakatoa. Oh, there is somebody who thinks that Krakatoa was slightly more, but at any rate, it's one of the 2 most interesting events from the Earth's surface to go up into the air. In the lower right, I have a picture I found on the web, which has the orange bits there. So we're looking down from a satellite. The orange bits are lightning strikes, and this had the most concentrated lightning field ever. So this plume that went up had lots of stuff in it that rubbed on each other, and that made enough electricity that it then shot down to the ground or up to the cloud. So that was sort of scary as well. So it was a big explosion. Well, it had initial effects and then it had some later effects. So the first initial thing was the sonic boom, a pressure spike. It went kaboom, and that pressure spike traveled around the Earth 4 times at least in all directions. So it went out, went around, came around again and again. And people with just small barometers were able to see it the first 2 times. And then people with fancy barometers were able to see it the next 2 times coming around. So that's, I think, pretty amazing. you can't hear it after a little while. It was heard a little bit by people with good ears in Alaska, somebody said, but I'm not sure I believe that. At any rate, so that's the initial boom. And it went around and around and around. So then we had the plume itself kept on going. I mean, it spat stuff up for at least 12 hours. And that plume had a lot of turbulence in it and had latent heat released. And that triggered more waves for the 12 hours at least. So there was not just the initial boom, but all sorts of things coming out of that. And there was a large amount of volcanic ash that fell down mostly on the Tonga archipelago itself, and not much too far away. So I thought I'd show you some pictures of the pressure wave. So on the left-hand side here, we have Chicago O'Hare Airport, which has a barometer, which you need, of course, for airline calibrations. And so along the bottom is time. This is the day, the 15th, I guess, of January. And the pressure goes up as the day goes along. And then there's a yellow arrow from the left that points to a spike there. That's when the first blast came through from Tonga over California, over the Midwest to Chicago. And it went bloop. So they saw that. And then eventually, as the day gets on and we go toward twilight, the pressure goes down. And then there was the opposite side of the wave, which went from Tonga down past Australia around the South Pole, came up through Africa and Europe, and eventually over the Atlantic. And that came to Chicago as well. And so that's the right-hand yellow arrow. So it was detected both ways at Chicago, at the airport. All right, then in the upper right, we have another series of data points. This is from our own Gwen Griffiths. Thank you, Gwen. From a pressure sensor in his backyard. And there's a white arrow in the upper left and white arrow in the lower right, and they point to where the first blast came through, coming across the Atlantic to the UK. And then the other one is the one that went south from Tonga around the South Pole, came up through Africa and the rest of Europe. And so there's that one. So he detected both of them as well as Chicago did. I think that's really pretty cool. And then the one below it is the Welland Valley Amateur Radio Society. And evidently during COVID lockdown, they got bored and invested in all sorts of little bits of equipment. And out on one of the ridges, they have a pressure sensor, and they caught at least the first one that came through. So in this diagram, which I got from a paper by Wright, we have satellites looking down on the Earth and various other things, and they saw multiple ripples. So this is a paste up from different satellites, which are listed on the right-hand side there. And I think this is just lovely. So Tonga is put in the middle. That's the little red X in the middle of the picture. You can see off to the left is Australia, and then there's a little blue bit, which is New Zealand, which has a different measurement. But at any rate, you can see that there are these concentric circles going out from that explosion over a period of many hours. So I thought that was really, really kind of neat. Some of these measurements are microwave temperature measurements, some are albedo measurements, and they're various different kinds of things. Little GPS there as well. Well, the question then for us is, did the ionosphere respond to this volcano? And do ham radio contacts, which are a measure of the ionosphere, do they show any of these effects? Well, first of all, the measurements originally had shown that the volcanic plume extended up to 50 kilometers altitude. And that's pretty much the top of the stratosphere, but not into the ionosphere. So it could have stopped there, but at least it got into the stratosphere. And this bit I think is very interesting in that, excuse me, it said that this also affected climate change in that this volcano lofted pretty much a cubic mile of water over the thing, shot it up into the sky, and got it above the stratopause into the stratosphere. Now, the bottom of the stratosphere, the stratopause, is such that it retards things from going through it. So it isolates our tropopause from what lies above, pretty much. But this now had taken this huge amount of water and vaporized it. So water vapor now has been injected into the stratosphere, and it spread around the whole world in the stratosphere, but it couldn't rain itself out. In the lower atmosphere, things rain out in about 2 weeks generally, but in the stratosphere, it takes at least a year to rain stuff out because it has to really work to get through that barrier at the bottom. All right, so now we have a sweater, a coat around the whole Earth up at that level, which is made of water vapor, which is a greenhouse gas and shouldn't be up in the stratosphere. And that made a change in the Earth's climate, a step function. That year, it went up. Eventually, it did rain out, and then we have all the little climate change things going on after that. So did this volcano have any effect on the F layer, which is generally 100 to 200 or 300 kilometers up? It could have been that it wasn't affected at all, or it could have been that it was affected. Well, let's look for specific examples. This is what I thought when I heard about it. I thought, well, what could we possibly do here? Well, I found 3 regions that were of interest. One is the Pacific region between the Western United States and Maui in Hawaii. So the upper right, the northeast section of the Pacific Ocean, has a lot of radio traffic from the United States to Hawaii, and maybe that would show something, and indeed it did. Then there's the whole mass of the continental United States. If this blast got all the way to Chicago, hey, maybe it went to something else around the top of the United States. We'll look for that. And then the third one, which was Illinois in particular, that's the midpoint between Pennsylvania and Colorado. So this is, I always look at Nathaniel's data. This is one of his pieces of data. Anyhow. Rob, here's a print of one day from your things that you have listened to, the yellow lines. So you've heard Australia and New Zealand on the lower left, a little bit of Japan in the left part, and then a whole bunch of yellow lines go to the United States. So I looked at this and thought, well, that's what we need to look at, is this part in the middle over here on the right between Hawaii and California, that part in there. So I asked Bill to geofence a little area in there, a little rectangular bit in there, and see what was going on with those communications. So I want to say something about that numerical work, about numbers here. I've read a bunch of papers, and there are various different techniques who measured the when various parts of this wave came by, and they got speeds of 218, one group, another 330, 343, 414, and 667 meters per second. So there may well be 4 different types of waves going around here, and depending on what you're measuring, you get one or the other of them. So the one that it's going to come out that the radio things measures is mainly the 343 one, kind of in the middle there. So the distance from Tonga to Chicago is 11,398 kilometers. That disturbance from the picture I showed you, the graph from O'Hare Airport, came about at 9 a.m., 15 UTC. And the difference between that and 4:15 in the morning when this thing went off is 10 hours and a bit. So the velocity is the division of those and came out to be 295 or about 300 meters per second. So I think 300 is a great number. So that says that distances closer to Tonga from Chicago westward would have seen the effects of the blast somewhat earlier. So earlier than 15 hours is 8 to 14 hours. So then I looked for the data in Rob's set that took place between 8 and 14 UTC and looked for gaps. And the two that I picked out right away were one was from New Mexico to Maui, one was from California to Maui, and they were disrupted between 9 and 10 o'clock UTC. And that was just a nice time. I looked at eastward from Chicago and looked at the Illinois, well, pretty much right under Chicago, Illinois, place, the midpoint from WWV to W2NAF. And that came out to be about a little before 15 UTC, so that makes sense. And all of these gave velocities between 300 and 350 meters per second. So I think consistency is a wonderful thing. So I thought I'd show you what the data looks like. So this is the Northern Pacific part. Time of day goes along the x-axis toward the right. And on the left-hand axis is the distance from Tonga to the midpoint between Hawaii and the bottom one is California and the upper one is Hawaii to New Mexico. And these are particular people, W1CK, WS6VJT, whatever. And these are on an automatic sequence. So they just go kabing, kabing, kabing. And I have put green ovals where there were two particularly interesting gaps. Now there are other gaps as well, but these two gaps are the interesting ones in that they gave consistent speeds. So if you think of this graph, and if you think about extending it downwards off the page onto the floor somewhere, and the numbers for distance goes from 70 to 50 kilometers through 6,800 kilometers down to 0 kilometers, then you're at Tonga. Then the line connecting these two green ovals falls right to Tonga, which means they have the same speed. So what this says to me is that the ionosphere was nicely flat and mirror-like until between 9 o'clock and 10 o'clock on this particular morning. Something disturbed the ionosphere. It became all wobbly. And so the signal from, say, California bouncing at that wobbly point to Hawaii got shunted sideways and was not recorded at Hawaii. So there's a gap. Eventually, it settled down and became mirror-like again. And by 12 o'clock, you could see the blue dots resume their sequence again. So then I thought, well, what about the United States itself? What about the middle of the United States or something below Chicago or something of that sort? And this is the amalgamation of the radio spots, radio contacts, using all three of the big amalgamators, so RBN, WhisperNet, and PSK Reporter. And each of the little yellow or orange dots there is a certain number of contacts. We have the range, the skip distance going up to the left on the left-hand axis. And what we look for is some sort of bottom line of where the yellow dots stop and the blue dots are just there, the background of nothingness. And very often we see a sinusoidal variation. So this is quasi-sinusoidal. There are lots of people after like 20 hours, but other than that, it looks like, to me, like it started at about 1300 UTC or maybe 1400, and you can see it carry on like that. And that's the time for the middle of the United States to have a wave at 350 meters per second. Yay, Missouri. Okay, and then here's the one from WWV to Pennsylvania, where the midpoint turns out to be in Illinois. And this is Nathaniel's data. And you see that it was going along and things were happening, and all of a sudden the bottom drops out and it gets all incredibly messy here over here. And that transition from nice to messy turns out to be at about 1,500 hours right in there. And that's the right sort of timing to match this sort of disturbance, which is gradually moving itself around the Earth. So I want to point out once again that indeed, this is the Chicago airport one again, that first you see the wave coming from the western part, and then eventually you see the wave which has come around Africa and coming up from the other part of the Earth. So you see it twice. And let's look for that now. So this is a sum of all the radio signals in the North Pacific in that geofenced box. And this is for 5 days. So this is the day of the Tonga explosion in the middle. This is the day before that. This is the day after that. And look at this, right in the middle of this day, there's a big dip. And it goes down to 40. And it had started out at 160. Whoop! So you drop by 3/4, leaving only 1/4 of the contacts still going. Something disastrous happened at that point. And that turns out to be the right timing for this wave to come from Tonga at about 350 meters per second, past the midpoint of that box. And then I said, oh my God, look at this. Here's another dip the next day. Let's look at that. So here's these 2 dips circled. The brown line here is where the Tonga blast happened, and coming to the North Pacific the first time around gets you to the first red circle, but coming around the other way past Africa gets you the second one. I think that is just really sweet. Okay, this just tells about it. The first drop was 75% of the signal dropped away. On the second day, it was only 65% of the signal dropped away, but that's still more than half of them. And I think probably none of these people realized it was Tonga. They just said, oh, well, there's a little gap today. Turns out to be significant. And last I'd like to tell you about this, which just came out a month or so ago. This is from the people who do seismology, so earthquake stuff. And looking back in their data, they found, that they have a station on Fuji, and I forget what this particular one is, another island out there. This is Tonga down here. And they have these seismographs that sweep around. And they swept around and they found that there was something going on there. And this one swept around and said something is going on there. And then they talked to each other and found, this is way after the fact though, found out that they were same timing. And what time was that? It was 15 minutes before the thing blew up. So I think that's kind of useless. You can't really do much in 15 minutes to tell people who are on boats or fishing at an atoll to get off. But at any rate, so that now they're working on some way to figure out if that really is a precursor. So in a summary, the ionosphere was disrupted, not just the stratosphere, but all the way up to the ionosphere, and that ham radio detected that. Okay, the pieces of data were from California to Hawaii, from New Mexico to Hawaii. Thank you, Rob. The LSTID over the continental United States. The sum of reports over the North Pacific dropped first day 75%, next day dropped 65% for the long Great Circle route, going around the other way. And then from WWV to Pennsylvania was also disrupted by the initial blast. And the velocities were mostly 350 meters per second, and some were closer and slower at 300. Future work. Well, I got all sorts of plans. I don't know if any of this will come about. I'd like to check for more individual contacts, not just these 2 that I saw right away. Check for more regions of gaps. So to geofence different regions, the Northwest Pacific, the Southwest Pacific, compare with what other people in the literature have found. I'd also like to try to do model ray tracings of, could I model this whole thing in sight of sinusoidal oscillation at Tonga and see how far it gets, and to then compare it with the DTEC over the United States, which I already have. And then it'd be nice to really, I don't know if it's possible to set up a monitoring system of these sections of the Pacific, for instance, or other sections, and just have it look for sudden drops and then tell me there's a sudden drop and then go look for what the source was. Well, thank you for your attention. Any ideas?
I have a question, Mary Lou.
Sure.
I'm not sure if you know the answer to it, but a couple of questions. So with the volcano being under the ocean, and you said the steam affected the pressure wave or got into the atmosphere, would the same volcano that was above the ocean have the same impact, or was being underneath the ocean and the steam created, did that increase the impact? I was just kind of curious.
I have no idea.
Okay, that's fine. I was just curious of volcanoes above and below the ocean, if that impacted their influence on the upper reaches of the atmosphere and even the ionosphere. So, all right.
I believe it is thought that the water increased the coupling to the atmosphere.
Thank you, David.
Yeah, I understand that too, because you think that there's more physical mass. It's being shot up into the sky essentially, and that mass would have more of an effect than saying above the water, where
Well,
the mass would mostly be air. But
yeah, but rock, otherwise, if they're above the air, what they shoot up is rock bits.
rock and lava, yeah, true.
Rock and lava, and rock is 3 times as dense as water. So you might think that rock being shot up would be more important than water being shot up. But I don't know. They did think that this had tremendous energy, and that seems to differ from volcano to volcano, no matter what's above it. So,
Yeah, and
question now.
and of course, when you think of steam, you know, if you compress steam or put it in something in a compressed area and then let it expand, that's going to be a lot of energy, possibly, as opposed to the rocks and the greater mass going up. I don't know. It was just something that I was kind of curious about, because you would also, if you're above the ocean, you're going to probably have that heat and that steam. So, okay, enough on that. I was just curious.
Wouldn't the also that it's you know, you're going to shoot up a lot of various metals and minerals at a molecular level, and that's going to have some effect on the signal also.
And
Well,
you
you-
have to wonder if that would affect the sporadic E.
Yeah, so it you know, whether it's pure water or water with sodium chloride with salt in it, that's going to make a difference.
Right, right. And you think if it got these minerals and shoots the minerals up, if they get anywhere near the ionosphere, they're very conductive. So would we have was it a big meteor shower?
Yeah, and that was another question I was going to ask, was if this affected the auroras with those possible metals and different chemicals going up.
That would be cool. Yeah.
I doubt that it would have affected the aurora. First, it didn't, you know, it would have to have gone into the polar regions. Second, the aurora is caused by electron precipitation, which I don't know that that was happening at the time.
Right, and this is very near the equator. So it's in the south hemisphere, but only like 20 degrees south of the equator, nowhere near the polar regions. But wouldn't that be cool if you get one in the polar regions to shoot up? Wow.
Mary Lou,
Yes, Gary.
I've got a question. It's kind kind of related to the volcano and the atmospheric conditions. The Los Angeles fire out there with the Palisades and the Eaton fire going on as long as it has now and continuing with the smoke shooting up, is that going to have an effect on the propagation in the area or around California?
I don't know. Has anybody got any ideas? Rob, what do you think?
Yeah, because I was thinking about the tiny particles you were mentioning, the ionized gases and aerosols and things like that, stuff coming up from the houses burning.
I
And
think my
chemicals.
takeaway from that, and thinking back to Mary Lou's one slide with the amalgamation of all the different data sources showing the blast wave essentially leaving Tonga, is you cannot have too much instrumentation of many different types, because you never know when they're going to be applicable. And so for all of us and all of you who've got whisper beacons and receivers or transmitters that are on the air using CW or FT8 or whatever mode it is, it's going to come in really handy someday. It has many times, but it's just you don't know when it can be used and what it can be used for. So it's a good thing we're all doing a lot of that.
On a related note, last year, 2 years ago, the big Canadian wildfires here in Michigan, we got some of that smoke here. So, and it was noticeable with air pollution notices. And close your windows and check your filters on your HVAC system. So you've got to kind of, even though you may not have any scientific instruments to back it up, based upon the previous discussion, you can pretty much assume that, yeah, something's going to happen. What? We don't know. But
Well,
you'd be amazed if nothing happened.
well, the smoke
David,
is,
did you notice any difference from the wildfires in Canada on propagation?
We certainly don't. The thing is that the smoke, as Mary Lou said, it's very difficult for it to get up into the stratosphere, let alone to the ionosphere. But the smoke certainly, stays down at this level quite effectively, and certainly affects our terrestrial weather. And we get California smoke all the way out here in New England. We've had, a couple of years ago, the California fires had causing very significant air pollution here.
And I would think or guess that the smoke would definitely affect VHF, that it could affect that, but I wouldn't think there would be the pressure to drive it up higher, as I think Dave was saying, or that ripple effect, those waves of pressure going out from the fire. And I would think it would be more of your higher frequencies that would be affected, that are affected by line of sight and other things like that. The opacity of it would affect it. But again, I'm guessing. But I think I would think you kind of need that pressure to force it up high enough to impact, probably.
Yeah, if I could comment, I remember seeing a few talks when I was a grad student in Saskatchewan, and some of our department colleagues worked on aerosols and such, and they, I think pretty much the to get up to really high altitudes where, it may affect closer to the above the stratosphere, mesosphere, that kind of area, really high up, you have to have a really, really large and really, really hot fire. And I seem to recall that it was very rarely it occurred. And, at that time, this was in the late aughts, early teens, I think there was probably a forest fire up in the Yukon or something like that they thought that had enough to get it up there. But you really needed something really powerful like a volcano to actually get that up there. So something like the Palisades fire, the Eden fire, although big and effective, I don't expect it would be large enough to do something like that. But interesting nonetheless.
I'd like to ask a question about whether the effect that you were measuring with those traveling waves that occurred immediately after the explosion, those changes wouldn't have been caused by particulates, would they? I mean, they wouldn't have spread that fast. These changes you're measuring are caused by a different kind of shock wave effect. Or am I misunderstanding what's going on?
No, I think you got it right. It's kind of a shockwave thing. And the ones that reported changes in albedo were of the sort that the air was clear but it's got enough moisture hanging around that when you whop it, it makes a cloud.
May I say a few things?
But that would be delayed for quite some time, right? Those sorts of effects.
I don't know.
Or is a pressure wave going to cause condensation?
Something like that pretty quickly.
May I ask a couple questions? And
Sure.
then there's a couple things we need to address that are time sensitive. First of all, Mary Lou, thank you so much for addressing all this. And we want to also recognize that Mary Lou presented this in a very nice poster at the AGU meeting in December. And so that was really fun, wasn't it, Mary Lou?
It was great fun. It's the first time I've been to this huge convention, and it was really, really amazing. I had a lot of fun.
It was incredible. So along with that, have you I know Sharon Vadas came up and looked at your poster a little bit and had some questions. Did you get a chance to talk with her at all?
No, I never managed to get a hold of her. We kept missing each other. So
Yes, she's a very
bad.
yes, we'll have to make sure you get in touch in the future. Have you taken a look at the papers that she's published on this?
Yes, I've read a couple of them and I have to read them again.
But yeah, she writes she writes at a very high level.
Yes, she does.
Yes.
Yes.
But I think one of the comments that she gave me, and Sharon is an extremely prolific, high level person. One of the comments she made is that some of the people that looked at these sorts of waves got the wave mode wrong when they first published it. And she said her modeling showed like a different wave mode. And so I can't remember exactly which ones she was saying were what, but I did put the two of the papers that she wrote on the Tonga event and did modeling for in the chat. And I think it'd be interesting to see if you could read these papers and then tell us what your observations say in relationship to what her modeling efforts were.
Right. And I think, yes, and that's something that really interests me as well. I think the fact that there are 4 different speeds that fall out of these different measurements. So there's the 200, the 300, the 400, and the 600 meters per second speeds tell us that there are different waves that are coming along. And I think some of the waves come along the surface and just occasionally bubble up to the ionosphere. Others that come along and they go through the ionosphere itself at that higher altitude. So there's a lot of stuff going back and, going upwards at different times. And these are different kinds of waves, how they actually go. So I'd like to get that more cleared up. Yeah, but the ones that the radio contacts saw were mostly of the 300 meter per second variety. So we got to see what and they have different names of different people on them as well. So,
yes, there's like Lamb and
I don't know who Lamb was, but he had good waves evidently. So
yes.
he's one of the
and unfortunately that's an area that again I am not super strong in, but I'm aware that there are these different modes and we need to pay attention to them. But if people do look at those couple links I posted in the chat, they have a very in-depth analysis that uses very sophisticated modeling to understand how the volcano blast propagates its waves up to the ionosphere and around the world.
Right. And yes, I'd be very glad to give you the whole PowerPoint. I'll send it to Gary and he'll figure how to do that.
Thank you.
May I ask a small question? Oh, sorry.
Yes. Question?
Yeah, Mary Lou, I was taken by the slide that showed what you reported as the largest amount of atmospheric electrification of lightning being ever recorded. And it seemed to me that there must be in the atmospheric electricity community a lot of interest in what happened to the field potential, the electric field potential as a result of this, and an opportunity to correlate that with the radio frequencies with the radio observations that you're making. Just a quick summary: the upper atmosphere is about 400,000 volts positive relative to the surface of the Earth. And although the air is a leaky conductor and should discharge that in about half an hour, there are about 2,000 on the average thunderstorms going on around the Earth all the time, predominantly bringing electrons down to Earth and maintaining this field with the ionosphere positive and the ground level negative. But with that much electrification going on in that area, were there regional effects where the electric field was intensified or reduced? Were those lightning charges mostly cloud to ground or reversed, as a few normally are ground to cloud, which would lower the potential difference between the ionosphere and the Earth? Anyway, it just seems that there's another community out there that was also very interested in this. I'm not sure who they are and who's published in that area, but
I have no idea, but this sounds really exciting. Could you look up stuff, you know the right words, and see if you could find some people or things that they said at the time or soon after that, and then send it to all of us? That would be really cool. I am so happy I'm not in a little plane flying over that thing.
right.
Zappo,
Oh my
Zappo.
gosh.
Oh dear, that would be awful. Oh my golly.
Now, regarding coupling to the ionosphere, you know, Nathaniel and Gareth, maybe you can answer this, but what is the level of coupling between lower atmosphere gravity waves and the ones that we see up in the ionosphere?
Again, that's a very complicated topic and basically an entire field of research that we are working on. So if you just take a look at the to see how complicated it is, just click those links in the chat that start with doi.org, and you can read some very, very complicated papers that talk about just some of the coupling. But
Topic for a future HamSCIence call.
Yes.
Yeah,
I
so
think-
the smoke wouldn't couple, but the waves certainly do.
Right.
I think a very interesting kind of big picture takeaway of these coupling efforts, understand these coupling efforts, is that when the waves propagate upward, the waves that are generated at the bottom are not necessarily the direct waves that you see at the top. What happens is the waves that are formed on the bottom, they propagate up, and then they break at some level, and then they propagate up some more, and then they break, and they might propagate up some more, and so you get these what you call the first waves are the primary waves. Then after that next breaking, those are secondary gravity waves. Then after another breaking, they're like tertiary gravity waves. So basically, they say that the waves you see in the upper ionosphere are really known as higher order gravity waves. And hold on, I'll
Yes, we all know English or Latin, and we could say primary, secondary, and tertiary. That doesn't mean we understand it at all. Right?
I think just interesting too. Obviously, we're blending a lot of different science topics here, whether it's the ionosphere and what's happening in the stratosphere and lower, closer to Earth, and so on and so forth. So it's a lot going on.
Yeah. Well, interesting stuff. I'm really intrigued now, David, about the lightning. So see what you could find out about that.
I've been away from that community for quite a while. As a youth, I worked as a tech for Bernhard Vonnegut, who is basically the expert from the 1950s through the 80s in thunder and lightning generation and propagation, and learned a lot from him. But he passed away about 25 years ago. So I'll get into the Atmospheric Sciences Research Center data at SUNY Albany, which
Poke around, see what you can find.
let's see if I can find some stuff.
Yeah.
Yeah.
I have a small question, maybe naive.
What?
So thanks for the talk. I've noticed when you show the pressure wave recorded, I believe, at the Chicago airport, that there were two blips, and you explain why and why there was a delay. One was positive and the other was negative somehow from the baseline. Can you give them an intuition why there is this? Because it made me thinking of transmission lines in which if they are terminated or not terminated, you have some sort of reflecting wave, but this is not, it's a mechanical medium and it should be symmetrical, no? Maybe longer wave.
Right.
So sorry, maybe it's a stupid question.
No. And you should never say a stupid question. You say, maybe this is a naive question.
Yeah,
That's the word one uses. So I don't know. And I found it interesting that in Gwyn Griffiths' analysis also, it was positive and then it was negative when it came around the other way.
Yeah.
Gwyn, do you have any idea why? Are you still here?
No, I don't, Mary Lou.
Okay.
No, sorry.
But in two cases, it was that way. So-
We need to keep going here because there's a couple time sensitive things. So I think this is really good. And I mean, perhaps we want to continue some of this discussion next week regarding this topic. Because there's quite a bit here, at least have a few minutes if we don't have another speaker organized by next week. Okay, but one topic to ask, so frontiers, let me see if I can share my screen here. Okay, Frontiers journal, which we have published in before about all of HamSCI, they're having a special issue called the Heliophysics Big Year Education and Public Outreach Reports. And they're asking for basically abstracts of articles to be submitted by January 30th, 2025. And the deadline of the manuscript submission is July 4th. And so it's still accepting articles. And the background here is the Heliophysics Big Year, which is a NASA term, and we're calling this year's HamSCI workshop theme the HamSCI Big Year, is a campaign that celebrates the sun's influence across the entire solar system, including the Earth. And it talks about the eclipses and education, public outreach, and citizen science, and all of that. And we are able to submit all sorts of different types of articles, brief research reports, regular research, original research reports, different descriptions of general commentary about the field of citizen science, methodology, things like that. I've already, and the people who are organizing this, Christina Collins, who's of course one of our HamSCI members, she's the topic coordinator for this special issue, and we also have we have one of the topical editors is Gareth Perry, who is on this call. And so I think this is an opportunity for people who want to try to publish their work with citizen science to submit to this. So I've already spoken to Steve Serwin. Steve is planning on submitting his HFTDOA work as an article to this. I'm planning on writing a manuscript that covers, that's like an overview of the entire Festival of Eclipse Ionospheric, Festivals of Eclipse Ionospheric Science, FOEIS, do a big overview type of manuscript. I think Gareth's postdoc called Deep is going to do one specifically on solar eclipse QSO party results. Mary Lou, I wonder if you want to do, they have this brief research report. Maybe you want to consider writing your Tonga one up as a brief research report.
I don't think that has anything to do with heliophysics, but I would like to do something with the personal space weather data.
Okay, it actually does have to do with the so no, the Tonga one actually, it does. So heliophysics, this is a very broad term, and it includes efforts that are not only during the heliophysics year, but are before. So anything that's HamSci and the ionosphere can fall within this topic. So yes, if you'd rather, the important thing is you can do something else if you'd like, but the important thing is that the deadline for submitting an abstract is January 30th.
Yeah.
So that's the thing to think about. Gareth, would you like to say anything about this since you are a topic editor?
Yeah, thanks, and then you covered a lot of it, and yeah, I just wanted to comment on Mary Lou's. Like, yeah, if you just submit a summary, and I think the probably the editorial board could probably be swayed. I mean, really, if it's yeah, that I think put it in and let us kind of decide and err on the don't worry about erring on the side of caution. Just fire it in there and we'll see what we get.
It's just silly.
Yeah.
So something to think about. Now, one thing I need to think about with this is the summary that I'm planning on submitting is exactly the AGU, one of the AGU abstracts I submitted or presented at the fall AGU meeting. And that presentation was this one. So I'm planning on submitting a summary that's results of from the 2023-2024 HamSci Festival's Eclipse on Atmospheric Science and what comes next. And I'm just submitting the exact same abstract that I presented on at the AGU meeting. And so I'm going to use my AGU talk as the beginning outline for the paper. One thing that I have to consider, and maybe we can think about this next week, is the co-author list. And the trick with this is we want to be as inclusive as is appropriate. But if what we learned with doing this, doing the last Frontiers paper is that when we have a very long co-author list, if we make any changes to it somewhere along the way, it becomes a very big headache. So perhaps next week, at next week's meeting or with some people offline, we can review this co-author list before we submit it, because if we make any changes to it, it becomes very, very difficult. So, and they also, when you submit a very long co-author list, it also raises some red flags because they're like, did everyone here actually help co-author the paper? And of course, this is a citizen science project and it's very large scale. So we were able to justify that the last time we did a Frontiers paper, but it is actually something we really need to think about before we just submit the summary. So maybe we can revisit that next week before this, because next week is the 23rd is our next HamSCI Telecon. So we still have a little bit of time before we actually have to get this submitted by the 30th. The other thing is we wanted to talk about HamCation here. And Ed, you're going to HamCation?
Yes, I am. Mm-hmm.
All right, that sounds wonderful. So we have, now you don't have anything formal for HamSci programmed into HamCation yet, do you?
That's correct. Mm-hmm.
Okay, but we do have HamCation advertised in the newsletter.
You mentioned it, and that's correct.
Says, come by and stop and visit HamSci.
Yeah.
So we were talking about this morning, perhaps if you don't have a formal table, maybe we want to do something like, have a meeting spot or meet up for lunch or dinner.
Yeah, and I had an earlier conversation with ARDC about maybe just borrowing a little space, so that might work out for us as well too. So.
Oh, that sounds great. And Kukai is also planning on being at HamCation this year. So do you know who Kukai is?
Yes, I do. Yep. Yeah, we met in
okay.
Scranton. Yep. Mm-hmm.
Good. So she will be there. And so perhaps she's very busy today. So she's working on something today, special assignment. But she can coordinate with you over the next
Yeah,
couple
sure.
of weeks.
Yep,
And
no
if
problem.
Gary also had the idea of we could get more of these printed and send them to you, and
Sure.
you could put them on the ARDC table.
That'll be
And
great.
last time I had these printed, we printed 200 and it cost $450. I think we can do that again.
Mhm.
I think I can do that again. Do you think that would be
Yeah,
worth
that'd be
it
fine.
too?
Yep, that would be
Okay.
great. Yep, yeah, just
So
send it. I'll give you the address because I'm here in Jupiter, so.
okay, great. Yeah, so go ahead, email me the address, and then
Mhm.
I'll coordinate and have these printed and shipped to you.
Great.
And then that way you can distribute these as well.
Yep. And
Great.
shake a lot of hands, you bet, so.
Yes. And so yeah, these are absolutely beautiful. I don't think you had a chance to actually see the glossy version of these yet, have you, Ed?
I saw one copy, so I think, yeah, I'm good on it, so, yep.
Okay,
Yeah.
so yeah, because they're really nice. All right, thanks. And then also we've had a lot of discussion regarding AI usage in using Chat GPT in research, and a number of people are finding it to be a very invaluable tool. And I'm also finding it to be very interesting. I just wrote a draft job description for a VLF research engineer, or had Chat GPT write it, and it came out quite nicely. So actually, I can show you. This is only a draft, but I actually went through trying to where is it? Grants. So as part of the DAISY 2 grant, we are able to create a research engineer position. And I uploaded a copy of the grant proposal to ChatGPT, and I gave it a prompt that basically said, please write a job description for a part-time research engineer focused on VLF, the VLF module development for the Personal Space Weather Station at the University of Scranton, and it gave me this document.
I heard an interview the other day with the president of LinkedIn, and he said this is a problem, especially in academia, for when a student turns in a paper, or if a candidate for a job turns in a resume. How do you know they really wrote it and it's legitimate versus something an AI machine learning thing did?
So these are all excellent questions, and I'm not going to try to answer them all here, but that's a great lead into the fact that NASA Citizen Science is organizing a webinar, a lunchtime webinar about the future of artificial intelligence and citizen science. And so there's going to be a discussion on February 6th, and I just sent this out to the HamSCI listserv. So if you are interested in being part of a webinar or a larger discussion about the use of AI and citizen science with people, with actual NASA officials and other researchers, just go take a look at that, and you can continue the discussion there. Anything else for? Yes.
Yeah, I was wondering, I had noticed that Cedar had a call for papers on ionospheric imaging. I think the deadline, unfortunately, was yesterday, but do we have any that have been submitted to that?
I don't know of any.
I guess not. Sounded like exactly what we do.
Yes, there's quite a few things going on. All right, was there anything else for today, Gary?
No, that should cover it pretty well. I think we've used up the hour very, very well. Next week, I believe we'll have Diego Sanchez, who's working on his master's at the University of Scranton, talking about the observation of large-scale TIDs using 14 megahertz amateur radio data. So should be pretty good, I hope.
Hey, Nathaniel, just very quickly, I know we're late. Do you have a target date for having the HamCon, the HamSCIence convention here in Salt Lake City, Utah?
Do you have a target date? I don't know.
And then that way I could come and I'm sure that that's the hub with so many members here, you know, besides me, there's got to be at least maybe one. Anyway, I just wondered if you had a target date. Everybody have a good day. Take care.
Thank you. I know have to talk about that. All right, everyone. Thank you so much. Have a great day.
Thank you,
Bye,
Mary
thank
Lou.
you.
Everyone have a great week.
Thank you, everybody.
Bye.
Be in touch.
Okay.